Hello, chemistry. This is Mr. Decker. I'm here to help you understand Coulombic attraction. Coulombic attraction is when two oppositely charged particles experience an attractive force. What this means is if you have a positive charge and a negative charge, they will attract towards each other. In chemistry, so far, we've learned about two particles that have charges. One is the proton, which is positive, and the other is the electron, which is negative. There are different ways that you can affect the force of Coulombic attraction. One of the ways is by changing the distance. If you have a proton and an electron, and they are close together, they feel a very strong force of attraction. However, as you increase the distance between them, the force of attraction lessens, and they feel less of that force, until eventually you can get them far enough apart so they feel no force. This same thing happens in atoms. We know that elements consist of protons in the nucleus and electrons on the rings. If I have an element that has electrons very close to the nucleus, that electron feels a very strong force. And we can show that by using a thick arrow. However, if I have an electron that is farther away from the nucleus because it's on a larger ring, that electron experiences a weaker force. Finally, if I have an even larger element that has even more rings, if I have an electron all the way out on this fourth ring, that electron experiences even less force. As the distance increases, the force of attraction decreases. Distance is only one way that Coulombic force can change. Another way to change the force of attraction is by changing the number of charges. Let's look at how the force changes when we change the number of protons. If you look up here, in this first row, we have one proton and one electron. Notice that the force of attraction is 2.3 nanonewtons. When I add another proton, the force of attraction doubles from 2.3 to 4.6. If I add another proton, the force increases even more. And if I have 4 protons, you'll see that the force is 4 times bigger than where it started. Another interesting thing about Coulombic attraction is how the force is not divided up if there are multiple charges. In this example, we have 2 protons and 2 electrons. You might expect that the force of attraction on each electron would be smaller because there's 2 of them. But the force of attraction each electron feels is the same. That's because this electron and this electron have no impact on each other in this situation. All they experience is the attraction due to the protons. So, just like in the previous example, when you have 2 protons, force of attraction on each electron is still 4.6 nanonewtons. Let's take a look now at how number of protons can affect Coulombic attraction in elements of similar size. Here I've drawn 3 different atoms: sodium, aluminum, and chlorine. Notice that all 3 atoms have the same number of rings. Also notice that they have different numbers of electrons on their outer ring. One of the things that we know is that all elements have different number of protons. Sodium is element 11, and it has 11 protons. Chlorine is element 17, and it has 17 protons. Notice that the force of attraction for chlorine's electrons is much stronger than for sodium. This is because chlorine has 6 more protons than sodium. You might expect that they would have the same force because chlorine also has more electrons. But remember, it doesn't matter how many electrons are in that ring because all of them experience the same amount of force. Therefore, 17 protons will create a much greater force than 11 protons.